So what am I dividing by 4 on this left-hand side? Everything, right? So should I go ahead and go to fractions, or should I leave it like this? I mean, this is a fraction too, right? Am I splitting it into 2 parts, or do you want me to leave it as 1 part? Okay, so I have x plus 6 over 4 equals cube root of y plus 5. What do you think? How do I undo a cube root? Cube it. So obviously I'm cubing that thing. What am I cubing on the left-hand side? So what should I add then? Parentheses. Okay. So on the left-hand side I have x plus 6 over 4. And on the right-hand side I have, oh, that's not true, cubed. And on the right-hand side, what do I have? Y plus 5. How do I solve for y? Subtract 5 from both sides? Guys, what am I subtracting 5 from over here? Oh, all of it? So I don't subtract 5 from 6 or 4? I have x plus 6 over 4 cubed and then minus 5. Does that make sense? Is that it? If I start in function notation, I need to end in function notation. So this is an inverse. I need to make sure I'm writing it in the correct notation. X plus 6 over 4 cubed minus 5. Yeah, that's a really difficult one. Okay. Any questions upon finding inverses? Nobody? Awesome. So let's do some transformations. Okay? If we're talking specifically about cubics, yes. The parent function is what? X to the third, right? Okay. You mean to just jump to a really hard one again? Okay. So tell me how this moves compared to its parent. How is it different compared to its parent? What does that negative sign cause? So I want to make sure we're using the correct math vocabulary. Over what? Where is the negative sign? It's on the outside of the function, right? If it's on the outside of the function, it causes some sort of vertical change. If it's causing a vertical change, what axis is it reflecting over? Good. Okay. Next is the 4, right? So what kind of change does the 4 cause? Where is it? It's on the outside, so it's causing some sort of vertical change. It is a multiplier, so it causes either a stretch or compression or shrink, depending on which word you like better. I don't care. This is greater than 1, so it's a stretch, right? By a factor of 4. What's next? The 5, okay? The 5 is where? If it's inside, what kind of change does it cause? Horizontal. It's being added or subtracted, so it causes a shift. And what's the most important part of that word? The F. Don't forget that. Okay? Since it's being added or subtracted, it's causing a shift. Since it's inside, it's going to move opposite of what we think. We think it should move right because it's plus 5, so we know it's going to go left, 5. And last but not least, Good. So just to make sure that I can go through my little spiel real quick, the 6 is on the outside. Since it's on the outside of the function, that causes a vertical change. 6 is being added or subtracted, so it causes a shift. Since it's outside, it's going to move exactly like I think it should, which means it should go up 6. Okay? So here's what you need to remember, because the next thing it's going to ask you for is the domain and range. Okay? Do you remember what a cube function looks like? Can I remind you? Something like that. That makes us really happy. The reason it makes us really happy is because domain-wise, how far left is this going? And how far right is it going? The domain, or all real numbers, right? What about the range? How far down does it go? And how far up does it go? I like cubics because their domain and range are both all real numbers. Always. Okay, if it's a cubic function, no holes or anything like that, x doesn't equal 6 or something ridiculous like that, then yes, domain and range is always all real numbers. Here's what also makes me happy. Okay, if I have the line y equals x, which means I reflect across that line to get cube root function, it would look like this, right? So this is y equals x to the third. This is y equals cube root of x. What do you notice about its domain and range? It's also all real numbers, both of them, because it goes here and up to here. Okay? That's really nice. So we have to remember that. We have to remember if it's a cube or a cube root, it's all real numbers, because remember what it looks like. Okay? Now what if it's to the fourth root? The fourth root or to the fourth. What does a function look like if it's squared? Looks like a parabola, right? So its domain is all real numbers, but its range is different, right? This is y equals x squared. Now, I'm over dramatizing some of these just so you can see them, just for the record, okay? Again, I'm over dramatizing some of these terms right here so you can kind of see a pattern that I'm trying to get you to see. I'm just trying to get you to see a pattern. This is x squared, this is x to the fourth, this is x to the sixth. This is x to the third. What do you notice about what's happening at the ends? It's called end behavior of the even functions. They're both going the same direction, right? What happens with odd functions? Opposite directions. What do you notice about domain and range of this one? All real? All real? All real. So if it's odd, if it's an odd exponent, it's going to be all real. That's really nice, isn't it? If they're even, what's the domain going to be? All real, but the range is what we have to watch out for. Okay? It's going to stop at some point and go back up the other direction, the same direction it came from. Okay? So, how do you feel about transformations of cubics, or really we could do this for the 4th or the 5th or the 6th, couldn't we? How do you feel about that, transformation-wise and domain and range-wise? Yes? Any questions?